what do you mean by an RC integrator circuit? Well, my name is Rishi Remju. Welcome to the Backbench Engineering Community, where I make engineering easy for you. So, let us ask ourselves the obvious question. What do you actually mean by an RC integrator circuit? Well, but for now. So, an RC integrator circuit. So, this is basically an electronic circuit that can integrate a particular voltage. That is, if we give an input voltage, say Vi, then the output voltage V0 would be equal to a particular constant K into the integral of this particular input voltage Vi. This is what you refer to as an integrator circuit. So now here an RC integrator circuit is simply but an integrator circuit that is built with two components, which is a resistor and a capacitor. So let us now construct an RC integrator circuit. So here first we would have the first term, which is a resistor like this, and here this resistor is now connected to a capacitor like this. So here this simple circuit is an RC integrator circuit. So here what we have to prove is that if we give an input voltage Vi over here, the output voltage V0 must be equal to a constant into the integral of this particular input voltage. So now let us give an input voltage Vi over here, and let this be R and let this be C. Then we are supposed to get the output voltage V0 over here. Let the voltage across the resistor be taken as VR. So now here we know that when we give a particular input voltage Vi, voltage can neither be created nor be destroyed. So therefore the Vi is equal to the sum of all the other voltage drops that are present here. That is, Vi is equal to VR plus V0. This is a fundamental equation. Let this be taken as equation number A. And now across the resistor R, in the resistor R, according to Ohm's law, we know that if the current that is passing through this particular resistor is I, the same current would be passing through this particular capacitor I. So therefore, if the current passing through this particular resistor is I, then VR is equal to I into this particular resistance R. But we know that I, that is the current, is equal to the rate of change of charge that is flowing, that is the amount of charge that is flowing per time. So therefore substituting this in this, we would get, this implies VR is nothing but dq by dt into R. I'm just writing the R over here, which is R times dq by dt. Let this be taken as equation number B. And now across the capacitor C, we know that according to the capacitance law, the charge Q accumulated across this particular capacitance Q is equal to CV. And therefore the voltage V0 is nothing but Q by C. Let this be taken as equation number C. So now breaking equation B and C and putting it into this particular equation A, we would now get Vi is equal to VR, which is R into dq by dt, plus V0, which is Q by C. And now here we are going to make an assumption. We are assuming that the value of this particular resistance R and this particular capacitance C is very large. We are assuming that the value of these two components, that is the resistor and the capacitance, are very large. So if the value of the resistor and the capacitance are very large, which means that the value of this C is very large. And since this C is in the denominator, it implies that this entire term is very small. So therefore, since R and C are very large, here R into dq by dt is very much greater than Q by C. And therefore, this particular term becomes Vi is equal to R into dq by dt. And therefore, taking R over here, we have 1 by R multiplied by Vi is equal to dq by dt. And now on integrating both these sides, we would get 1 by r into integral of Vi is equal to the integral of dq by dt. So the integral of dq by dt is nothing but q. So here 1 by r into integral Vi is equal to q. But from equation C we know that the value of q is equal to C into V0. So therefore substituting that over here, we would get 1 by r integral Vi is equal to the value of q is equal to CV0. CV0. Or on rearranging this, we would get V0 is equal to, taking the C over here, we would have 1 by RC into integral of Vi. So here the value of R and C are constants because the value of resistance and capacitance is a constant. So therefore here we would get the output voltage V0 is equal to a particular constant multiplied by the integral of the input voltage. This thus is the mathematical explanation for an RC integrator circuit. This simply is what you refer to as an RC integrator circuit. As simple as that, guys. This thus is simply what you refer to as an RC integrator circuit. As simple as that, guys. There's nothing more to it. So I hope you guys now have a understanding of what you refer to as an RC integrator circuit. And if you guys found this video informative, please do hit the like button and join this community by hitting that subscribe button. We'll be discussing about the further topics in the upcoming videos. So stay tuned, stay subscribed. Until next time, I'll see you in the next video. Thank you.